going to fit a linear regression model in Stata using the Framingham example of regressing systolic blood pressure at exam 2 on the predictor systolic blood pressure at baseline at exam 1. To fit a regression model in Stata, you're going to go to Statistics, Linear Models and Related, and then choose Linear Regression. In the box marked Dependent Variable, you're going to select your outcome, and independent variables, you're going to put your predictor variable or your covariate. The dependent variable is systolic blood pressure at exam 2, and the independent predictor variable is systolic blood pressure at exam 1. Once you've filled in your variables, just go ahead and hit OK. The linear regression command in Stata is just called regress. The first variable that's in the command line is the outcome, and then after that are your predictor variables. Important information from the output includes the sample size, which in our case is 89, corresponding to the number of observations. Additionally, we want the regression coefficients, which are all contained in this box. The coefficient corresponding to the underscore CONS, or the constant term, is 30.1. The coefficient for systolic blood pressure at baseline, which we've also called the slope parameter, is this 0.81. For each line in the regression table, you're given more than just the estimate of the parameter. You're given the parameter estimate, the standard error of that estimate, the t-statistic corresponding to a test that that parameter is equal to 0, and the p-value corresponding to that test statistic. Additionally, we get 95% confidence intervals for each of the regression parameters. So in this example, if I were particularly interested in the change in systolic blood pressure at exam 2 on average for a 1-unit increase in systolic blood pressure at exam 1, I would focus on the sys-BP1 line. The estimated coefficient is 0.81 with standard error 0.08. This leads to a test statistic of 9.8. That test statistic follows a t-distribution with n minus 2 degrees of freedom under the null, so it would be 89 minus 2 degrees of freedom, which is equal to 87. And this results in a p-value that's very statistically significant for a test of the null hypothesis that this slope is equal to 0. So it does seem like there's evidence of a positive linear relationship between systolic blood pressure at exam 1 and systolic blood pressure at exam 2. And then the last thing that we're always going to be interested in is this 95% confidence interval in the slope.